All right. Well, we can go ahead and get started. I know some more people will be trickling in as we start. I think good afternoon, everyone, and I really appreciate. Thank you for joining us for this month's webinar. I think over the next 30 minutes, we're going to discuss some of the most common challenges we see in ArcGIS Enterprise environments, the business risks they create, and a practical framework for building a more secure, scalable, and proactively managed GIS platform. And since we're presenting through Microsoft Teams today, please feel free to submit any questions in the Q&A as they come up. We're going to keep an eye on them throughout the session, and we have some time set aside at the end to address as many as we can. So here's a quick roadmap for today. We'll start by looking at some of the common warning signs we see across ArcGIS Enterprise deployments. Then we're going to discuss why these technical issues are actually business risks. And from there, we're going to introduce a 4-pillar framework for building a well-architectured ArcGIS Enterprise environment, discuss some deployment options, including on-premises, cloud, and hybrid architectures, and finally share how Blue Raster helps organizations assess and manage their GIS infrastructure. So before we jump in, just a quick introduction of the team. I'm Lee Hartman. I'm a program manager here at Blue Raster. I work with our clients to align some of their ArcGIS Enterprise goals with the right support approach and really help ensure their environments are secure, reliable, and delivering value. And joining me is Chigo Ibe, one of our project managers who oversees many of our ArcGIS Enterprise implementations in managed services engagements. And finally, we're also joined by Andrew Orton, our cloud DevOps engineer, who specializes in enterprise architecture, cloud deployments, monitoring, and platform operations. And together, we've worked with organizations ranging from local governments to nonprofits to commercial organizations managing mission-critical GIS systems. And for those that may not be familiar with Blue Raster, we're a GIS consulting firm headquartered in Arlington, Virginia, and we've been helping organizations apply GIS technology since 2002. We're an Esri Gold partner and also a partner with Microsoft, Google Cloud, and AWS, which allows us to support clients across both GIS and cloud infrastructure needs. And our team specializes in web application development, ArcGIS Enterprise, and managed services. And while we're a small business, we support clients across the United States and internationally, helping them turn geospatial technology into better data, smarter applications, and stronger outcomes. And one of those reasons we're excited to speak on this topic today is because ArcGIS Enterprise is something our team works with every day. Over the past 20 years, we've supported more than 150 ArcGIS Enterprise deployments, worked with over 80 cloud services clients, and currently provide ongoing support to more than 40 managed services clients. And that experience has given us visibility into what successful organizations are doing well, where common challenges emerge, and the best practice that keep enterprise environments secure, scalable, performant, and proactively managed. And many of these lessons we'll share today come directly from those real-world engagements. Now, I'd like to start with a simple question. If your ArcGIS Enterprise environment went down right now, how long would it take your organization to know? Would your GIS administrator receive an alert immediately? Would your operations team know within minutes? Or would the first indication come from a frustrated user calling the help desk? And for many of the organizations, it's actually the last one. And that's really what inspired today's webinar. The goal isn't simply to keep ArcGIS Enterprise running. The goal is to know what's happening before your users do. So as we talk with organizations across the country, we hear the same challenges over and over again. I was mid-demo presenting our mapping app to stakeholders when one of the layers stopped showing up. Our field crew quietly stopped using the mobile GIS app because it kept lagging and nobody told us for months. We found out our service was down because a frustrated customer called in, not because our team caught it. Or our GIS platform is 3 versions behind because upgrades keep getting bumped for more urgent priorities. These aren't unusual situations. In fact, they're some of the most common indicators that a GIS environment has become reactive rather than proactive. When we group these examples together, they actually fall into a few common categories. The first is a map service outage. A critical service goes down during an important public-facing event, but there is no alert or warning. The team only finds out once users are already impacted. The second is silent application erosion. This is when applications gradually become slower or less reliable, but no one submits a ticket. Users simply stop trusting the tool and quietly move back to manual workarounds. The third is having no early warning system. Instead of operation teams identifying issues first, downtime is discovered by end users or help desk calls or frustrated stakeholders. And finally, there is security perpetually deferred. Patches and upgrades get pushed to the next cycle, version debt builds up, and risk compounds over time. Individually, these may feel like technical issues, but together they create business risk, reduce user confidence, and make GIS teams spend more time reacting instead of planning. So before we continue, I'd love to hear from you. Which one of these challenges is most relevant to your environment today? And I'm going to use the polling function in Microsoft Teams, and I'll launch that right now. It should be popping up on your screen. Just take a second and choose the one that is most relevant to your environment. Right. Seems to be a dead heat for A and C so far. Oh, we're getting a pretty decent spread between them. I'll give you like 15 more seconds if you want to populate it. This is really helpful for us as we want to make sure that we focus and emphasize on what's most relevant to you and your environment. All right. Well, it looks like maybe A is coming out ahead. Slow maps and applications impacting adoption. So Andrew and Chigo, maybe one that we can highlight as we continue going on. But yeah, thank you again for taking the time to populate the poll. Again, just as a reminder, as we're going on, if you have any questions, please feel free to put it in the Q&A or the chat. We're happy to come back to it and answer some of those. So with that being said, I'm going to pass it over to Chigo Ibe. It's going to take us through the hidden costs of fit-for-purpose GIS.
All right, so in this section, we're going to be covering the hidden cost of fit-for-purpose GIS. This is a very important conversation to have when evaluating the long-term health of your GIS program. So to begin, let's understand what fit-for-purpose GIS actually is. At a high level, fit-for-purpose GIS refers to an environment that was built or configured to meet a very specific, limited need at a specific point in time and has been left largely unchanged. Now, here's the key concept. It gets the job done at a basic level, but it was never designed to scale, evolve, or support the growing operational demands of an organization. Think of it like this. Imagine you build a house for a family of 3. And now 10 years down the line, you have a family of 7. The house still functions. You can still sleep, you can still cook, you can still live your life. But is it serving you well? Is it optimized for your current reality? Probably not. That's what fit-for-purpose GIS is. It was the right solution for that moment, but the moment has passed. And that naturally leads us to the risk conversation. Organizations evolve, business needs evolve. So what happens when your infrastructure can't adapt to those evolving business needs? The risk is not in the fact that the system was built to serve a specific purpose. That's completely reasonable. The real risk is not recognizing when the purpose has outgrown the system. And that recognition doesn't always come with a loud alarm, right? A lot of the time, it creeps up on you very, very slowly. So we're going to walk through some of these specific business risks that we've identified from fit-for-purpose GIS environments. And as we go along this, I want you to think about whether any of these sound familiar to you. Well, risk number 1 is what we call the slow performance trap. There's a well-documented threshold in user experience research. If a system takes more than 8 seconds to load, users stop trusting it. And when that trust erodes over time, adoption erodes with it. In IT circles, this is called silent abandonment. Users will not file a ticket, they don't escalate the issue, they just quietly stop using the tool. But here's what it looks like in practice. So we estimate that organizations can lose approximately 40% of their platform ROI simply due to low adoption driven by poor performance. Not a system failure, not a security breach, just slow maps, slow applications, and users who have quietly found a workaround. The troubling part about this is you may not even know what's happening because nobody has complained. And that brings us to risk number 2, which is especially relevant for smaller GIS teams. And that's the single point of failure problem. In a fit-for-purpose GIS environment, it's very common to have one person who holds all of the institutional knowledge. They know how the system was configured, they know the upgrade history, they know the workarounds, right? However, there are no documented runbooks, no succession plan, no playbook for when that person is out sick or when that person leaves the organization entirely. This is a structural risk. It's a single point of failure, and it's a recipe for operational disruption at the worst possible time. The organizations we work with that have the most resilient GIS operations are the ones that actually have adequate documentation, contingency plans, and have made knowledge transfer a core part of how they operate, not an afterthought. And then we move on to risk number 3. Risk number 3 is security exposure, and specifically what we call patching lag and version debt. Now, this is another one that tends to creep up slowly and quietly, which makes this one particularly dangerous. This usually what happens when patching windows and version upgrades are deprioritized. Looking at this graphic here, you skip a patch in cycle 1. You're a version behind in cycle 2. By cycle 3, you're looking at a compliance risk. In cycle 4, you have an open vulnerability. By cycle 5, you have an actual full-on security exposure. Now, the reality is nobody wakes up and decides to leave their systems unpatched or upgraded to the latest version. What happens is that patches or upgrades are not prioritized. They get bumped up to the next quarter and then to the next quarter and so on and so forth. There's always something more urgent. But each deferred cycle compounds the problem. And eventually you're sitting on a level of version debt and security exposure that's genuinely difficult to recover from quickly. So looking at this slide, I hope it's a slide folks here are familiar with. And if it's not, I will say ArcGIS Enterprise usually comes with some level of information around extended support, maturation, and retirement timelines for the various versions of ArcGIS Enterprise. I implore everyone who already has an ArcGIS Enterprise environment to be familiar with this table. And if you need resources around this, we're happy to provide as well. And that leads me to risk number 4, which is about scaling, or more accurately, the inability to scale when the time comes around. So systems built for yesterday's demand cannot keep pace with today's operational needs. There's so much going on in the world today. Analytics, AI, you name it. And what we consistently see is that when organizations need to scale reactively in response to a new program, a new user base, a new data requirement, it's almost more expensive, more disruptive, and more damaging to the overall architecture quality than if scaling had been planned ahead of time. Every unplanned addition strains the existing environment. And over time, you end up with an environment that has been patched together rather than designed. Proactive intentional architecture planning is the differentiator here. Organizations that scale efficiently are the ones that are built with their future roadmap in mind and not just their current needs. Well, the good news here is that every one of these is fixable, right? These are not edge cases. We see these every day. And critically, you don't need a full platform rebuild to address them. Now, I've talked a little bit, so I understand hearing a list like this can feel overwhelming and exhaustive. But what it actually requires is intentional architecture, proactive management, and a right operational discipline applied consistently over time. So in the next section, we're going to shift away from talking about the problems to the solution and walk through what a well-architected ArcGIS Enterprise environment actually looks like in practice.
All right, so what is a well-architected GIS system? A well-architected GIS system, it's scalable, secure, and resilient. It's designed with intentional infrastructure planning, proactive monitoring, and established best practices across performance, security, and operations. So it's built to grow with the organization, it minimizes downtime, and it supports multiple users and workloads simultaneously. And this happens whether it's on-premise, in the cloud, or a mix of both, or a hybrid deployment. So for a WebGIS deployment to be well architected, it needs to accomplish the following things. It needs to be secure, and it needs to be scalable. It needs to be performant, and it needs to be actively managed. So first, we're going to look at security. So to build a secure deployment, you need to follow the best practices that are found in places like the ArcGIS Enterprise Hardening Guide put out by Esri, and then there's also the ArcGIS Architecture Center. So these practices include IT concepts like encrypting data in transit and at rest, using network segmentation and firewall rules, implementing a single sign-on experience for authentication, and then using the principle of least privilege for authorization. And you need to establish a regular maintenance schedule to install patches to prevent exposure to known security vulnerabilities like Chigo highlighted with that chart. So for the security pillar, an example of this is the work we did with Stearns, Weaver, Miller. So they are a law firm based in Florida that specializes in real estate. So they're very focused on securing their clients' data. And they were encountering some issues when they were trying to go through that ArcGIS Enterprise Hardening Guide, specifically around the Web Application Firewall configuration, or the WAF, for their cloud-based deployment. So we help them with carefully reviewing all the rules to make sure that they were blocking external access to all those administrative endpoints in Enterprise, but also they needed to make sure that they could accomplish their day-to-day business workflows without interference, so not being overly restrictive. So we also reviewed their security group rules to make sure that the only traffic that could enter the deployment was the traffic that needed to. So locking down IPs and ports so that nothing could get in that didn't need to get in. And then we also helped with implementing a single sign-on experience in accordance with their rigorous security protocols, just to make sure that the only people that could access that sensitive data were people that needed to. So after we finished work with them, they have a secure ArcGIS Enterprise deployment. It still lets them do everything they need to do to support their clients, but securely. For the next pillar, we're going to look at scalability. So this can be understood as the ability to support many users doing many different things at the same time. And it can also be understood as the system's ability to resize in response to increased or decreased demand. For a deployment to be scalable, one of the major concepts is workload separation. So you're separating out different workloads so that they're not competing for resources. One example of this is you have one server to serve imagery from serving imagery and performing raster analysis, another server for publishing services from your enterprise geodatabase, another server for processing real-time data from IoT sensors and devices. And then if we can go back to the last slide. So you also need to plan for future demand. You need to know how many users you have and how those users interact with the system. And then you also need to be ready to take action if the number of users grows or if usage patterns change or an app goes viral. So this might mean adding a machine to your ArcGIS server site. It might mean resizing machines to give them more processing power or memory, or shifting into a highly available configuration. So for this pillar, the example we're going to look at is our work with One Energy Renewables. So that's a solar energy company, and they have a GIS team that performs a lot of analysis on large national parcel data sets. And they needed assistance to move their deployment to the cloud, primarily for its advantages in scalability. So they have users on their team all over the country. So they needed a central location for their data and for everybody's workstations to be as close as possible to the data, which is a best practice. So we help them set up a virtual desktop infrastructure or VDI solution so that those cloud workstations can be added in little to no time as they onboard more analysts. And then it also streamlines the login experience using the Windows app. And this is in Azure, so that it's only a couple button clicks to launch and access that workstation instead of having to manually open ports and configure things in Azure and manually RDP onto jump hosts in order to access the servers. So just a better solution for them there. And also for the scalability piece, we configured a multi-machine ArcGIS server site so that they have the option to easily add more machines and server roles with just a few minor changes to the deployment configuration. So with this architecture, they're set up well for the future, and they can respond to any changes in their business needs quickly and easily. And the next pillar we're going to look at is performance. So while many think performance can be as simple as just tracking average service response times, it really can be subjective and very complex due to all the interlocking systems. So for example, you can have a service that's tuned and configured on a server that has plenty of available resources. But then if somebody is on the other side of the world and they're on an underpowered desktop and they're working with that service for heavy geoprocessing, they might say it's performing poorly just because their machine is not right sized and there's crazy network latency for being on the other side of the world. So it's important to use the appropriate tools to establish a baseline and do some load testing. So some good tools for this are jQuery, ArcGIS Monitor is great, and then there are other applications like Prometheus and then Grafana dashboards that can display this information and help with load testing. And also, it's not just one tier that you need to be concerned with, not just your services, but you need to consider all tiers. You need to consider the application tier, the service tier, and the data tier when you're configuring and tuning the deployment. So this means for the application tier, you're enabling scale-dependent rendering on your layers in your web maps, so they're not displaying all data all the time. On the service tier, it means configuring your services with the appropriate number of instances, and then also not enabling capabilities on the service that you don't need to. And then on the data tier, this means rebuilding indexes, recalculating statistics, and compressing the geodatabase as edits are made to make sure those queries are snappy. And this means revisiting all the above on a regular schedule. So for the performance pillar, we're going to look at Collin County, which is a large county of over 1 million people in Texas. It's just north of Dallas. And they needed a responsive GIS deployment to serve many different kinds of services, supporting many different departments, as well as their public-facing web maps and apps. So we implemented a multi-machine architecture on-premise, and we were focusing on workload separation so that multiple server roles don't need to compete for resources. So you'll see a separate machine for portal. You have 2 machines participating in the main hosting ArcGIS server site. There's another machine for the image server site, another machine for geo event, and then you have 2 different machines for the 2 different data store types. And then also we installed and configured ArcGIS Monitor to help them track service response time and maintain those responsive web apps. And it's the first thing they check every morning to make sure that the deployment is meeting their established baseline performance. The final pillar we're going to look at is proactive management. So well-architected GIS, it's not just a one-time exercise, like Chico said, for the fit-for-purpose GIS, but it's something that you come back to and just continually manage and improve. So going back to Lee's question, if your ArcGIS Enterprise went down, how long would it take your administrator to know? At a minimum, you need to have visibility into that server uptime and individual service uptime for your most used services. But really, you need to have eyes on all the other pillars, security, scalability, and performance at all times to make sure that the deployment remains well architected. Also, you need to have operational knowledge documented and updated as needed. So this would be the playbook for when the deployment was originally installed. This would be like architecture diagrams that you would need to update whenever you add servers, whenever you upgrade to another version, the history of that, and then what was done during the upgrade. And then also you need to have a documented recovery strategy. So what if the deployment goes down? What's your plan to bring it back online as quickly as possible? And then you also need a structured cadence for backups, reviewing the health of the deployment, then installing patches and planning for those patch windows and those upgrades. So for this pillar, we're going to look at Orange County. It is a county of about 40,000 people in Western Virginia. And their GIS administrator reached out to us because he needed visibility into the deployment in order to report back to higher ups at the county during the yearly review process. And he found that going through the logs to get a picture of the health of his deployment was just really difficult, and he wasn't getting the information that he needed. So what we did is we installed and configured ArcGIS Monitor. We created a custom analysis view that gave him all the metrics that he was interested in, displayed in a one glance, so he could get all the information he needs. He could get a total system downtime, which was the metric he was most interested in. But then he could also see what services are being used by those public web apps due to the item relationships in Monitor. And then he could also just make sure that those services got the resources they need. So that make sure that they had enough service instances. So armed with this information from ArcGIS Monitor, he can quickly respond to alerts and troubleshoot those problematic services before users even notice. And then more importantly, he can keep the deployment in good shape heading into his annual review.
All right, so we've just walked through the 4-pillar framework that we apply here at Blue Raster. And you've seen real-world examples of how that framework plays out in practice. A question we tend to hear often at this stage is, well, that all makes sense, but how do I choose the right deployment model for my ArcGIS Enterprise to support the framework in the first place? So the truth is, there's no universally right answer. And while that might be unsatisfying, the best environment is one that fits your operational reality, your security requirements, and your growth trajectory. So what we want to do in this section is give you the framework to make the determination for your own organization. So let's walk through each of the 3 deployment models. What I want to do is go through each of the models, look at their strengths, and the key considerations you need to weigh when making your decision. All right. So first up, on premises. Here, the strengths are very real. You have complete authority over your upgrade timing, your security configuration, and your infrastructure. For organizations with very strict data governance requirements, on-premises is often the preferred or required path. The considerations here are also equally real. On-premise environments accumulate a lot of version debt without operational discipline. The maintenance burden is high because you own the infrastructure, You own the patching, the monitoring, all of it. So for well-staffed teams, it's manageable, right? So you can take on the work because you have the staff to support. For lean teams, however, it can become a significant challenge. So the question isn't necessarily whether to stay on premises, it's whether you have the operational and staff infrastructure to run it well. Next, we'll talk about the cloud environment. This is a very popular option in modern society. You get faster deployment and scaling cycles, a shift from capital to operational expenditure, and a significantly reduced infrastructure maintenance burden. So for organizations with growing bases, growing user needs, and lean GIS teams, cloud could really be transformative for you. The considerations here are does require strong governance, and very importantly, it requires strong cost management discipline. Unmanaged cloud environments can generate significant unexpected spend. So data governance still applies here. You need to be intentional about where your data lives. The cloud option rewards organizations that come in with a plan. And last but not the least, there is the hybrid environment. The key phrase here is intentional architecture. The strength of a hybrid deployment is its flexibility. So you can let your cloud system handle the scalable public-facing workloads while keeping your sensitive on-prem data where compliance demands it to be. A good number of our clients land here because their needs aren't entirely one thing or the other. The consideration here is the complexity, right? Hybrid environments are the most complex to architect and maintain. So if the integration points, for example, between your on-premise and cloud components aren't managed well, you can end up with the complexity of both without fully capturing the benefits of either. For example, if your enterprise asset management system is on-prem, but your ArcGIS Enterprise environment is in the cloud, there could be pain points there trying to integrate both of them if the versions are not compatible. So when the governance and architecture discipline are in place, however, we see that hybrid could be a very effective model. So let's close with these three questions that should drive your decision. Question number one, what are your data governance and security requirements? Question number two, what does your internal GIS operations capacity actually look like? And finally, what is your growth trajectory and budget model? If you can answer these questions honestly, you should arrive at a sound decision around what deployment model you should take and what your environment should look like.
All right, Chigo, thank you. I think that brings us to the Q&A portion of today's webinar. We had quite a few questions come in as people were signing up for the webinar. And I see we had one come in just a few minutes ago from Daniel Shinnick. And I think, hopefully I pronounced your last name correctly. But Andrew Orton, maybe you can help answer this question. When you were talking through the 4 pillars and talking through performance, how do some of those recommendations translate to hosted feature services?
Yeah, absolutely. So hosted feature services in ArcGIS Enterprise, they follow a different model than like the configuring the service instances, like I mentioned at the service tier. Hosted feature services are ArcGIS managed. So the data is stored in ArcGIS data store and managed by ArcGIS server, and your option there for the performance of hosted feature services is there is an option to manage indexes through like the item details page in Portal or the item settings page. So it can be done there. It's just ArcGIS will handle all of that, and there's really not much to configure other than making sure your server machines are appropriately sized for data store and server in particular. Yeah, good question.
Yeah, thanks, Andrew. Another question that we got quite a few times from people signing up for the webinar. Chigo, maybe I'll pass this one over to you. How often should ArcGIS Enterprise be upgraded?
That's a great question. So the way we see it, I think you should have at least one in-place upgrade every year. Now, when it relates to patching cycles, our best recommendation here is to have a monthly patching cycle for regular patches. And now this is separate from security patches. We believe you should apply security patches as quickly as possible, but also open up a monthly patching cycle for regular patches that come for your ArcGIS Enterprise. As far as it regards to version upgrades, we strongly recommend having at least one in-place upgrade a year to keep up with the versions and stay away from version debt.
Yeah, thanks, Chico. And then another one for you, Andrew. How do you approach disaster recovery for ArcGIS Enterprise?
Yeah, that's a really important consideration, especially when you are looking to schedule those patching windows and the upgrades and things like that. So there are two things to consider. There's with backup and restore. So there's like a recovery point objective. That is like how much data can you afford to lose? So usually we do like daily backups, but in some cases organizations can't afford to lose that much data and they need more frequent backups. And then the second one is a recovery time objective. So that's how long can you afford your enterprise to be down? So that would be like, do you need a highly available deployment that if your portal or server or data store goes down, it can just cut over to the other one and there's zero downtime? Is that a requirement? Or can you be down for a couple hours while you revert to machine snapshots, which is one way. But really, you don't just want to rely on machine snapshots. We usually recommend two different methods. So like virtual machine snapshots, but then also there's a WebGIS DR utility that is included with ArcGIS Enterprise that essentially zips up your site configuration for portal, server, and data store. And then you can store it in a separate secure location, perhaps in like a Azure or AWS storage account. So we recommend both snapshots and the WebGIS DR to have two types of backups. And then also practice restoring them so that you know it'll work. And then scheduling the backup as well. So that's on at least a daily cadence.
Great. Yeah, thanks, Andrew. If anyone else has any questions, feel free to put it through in the Q&A function on Teams. We had one more question that came through from the audience. Andrew, how do I know when it's time to move from a single machine deployment to a highly available architecture?
Yeah, that's a good question too. So the single machine deployment, it's the cheaper option. You're only deploying one virtual machine, but Portal and ArcGIS Data Store, they both have internal databases that they use. Portal has one for to manage like or items and groups and users and all that stuff. And Data Store has one for the feature data. And databases, they can be pretty memory intensive. So I'd say the primary thing you want to look out for is like memory consumption on that virtual machine. But then another indicator is going to be your service response times. So if you see those kind of crawling up, combined with the memory consumption and overall machine health, then it's probably time to consider splitting out that deployment into a multi-machine configuration to give those different components some room to breathe so they're not competing for resources all the time.
Great. Yeah, thanks, Andrew. All right. Well, we have a few minutes left. I'll go ahead and get ready to close this out. So again, thank you for all of the questions and discussion. And again, thank you for submitting many of your questions like ahead of this webinar. I think as we wrap up, I wanted to bring this back to the practical next step. Like how can Blue Raster help organizations move from that reactive support to proactive ArcGIS Enterprise management? And I think one of the first areas is like an environment assessment. This is where we evaluate the current state of your enterprise environment across security, scalability, performance, and operational maturity. And the goal is to give you a clear understanding of what is working well, where there may be risk, and where your team should focus first. From there, we can support a gap analysis and a roadmap. We document what is working, what is at risk, and what needs to change, and then turn those findings into like a prioritized, actionable remediation path. We can also support ArcGIS Enterprise deployments. So whether you're implementing a new environment, modernizing an existing one, or planning for cloud or hybrid architecture, we help ensure the deployment is structured, scalable, and aligned to your organization's needs. And finally, we provide managed services, and this really includes proactive monitoring, scheduling health checks, documenting runbooks, patch cadence, and upgrade planning. And the focus is to keep your environment stable, secure, and ready for the need of your users. And ultimately, our goal is to help your team spend less time firefighting infrastructure issues and more time delivering GIS value to the organization. Please definitely sign up for some of our future webinars. We definitely want to encourage you to become a Blue Raster webinar series regular. Our next session is going to be on Wednesday, October 12th at 2 p.m. And we'll be covering what's new with the ArcGIS platform apps, including some highlights from the Esri user conference. And this will be a great follow-up for anyone interested in staying current on new Esri capabilities, product updates, and practical ways those tools can support your organization. And the registration link will be shared soon, so please keep an eye out for that. We'd love to see you at the next session. And for those of you that are attending the Esri user conference in San Diego, we would love the opportunity to connect in person. So please feel free to stop by our booth, attend one of our presentations, or simply introduce yourself if you see us around the conference. So as we wrap up, I'd like to leave you with one final thought. For many organizations, ArcGIS Enterprise has become a mission-critical infrastructure. It supports public-facing applications, operational dashboards, field workflows, executive decision-making, and countless business processes. And while the importance of those systems has grown, the way they're managed often hasn't evolved at the same pace. The organizations that are most successful aren't necessarily spending more money or building larger environments. They're managing their platforms intentionally with visibility, planning, governance, and proactive operations. So thank you again for spending part of your day with us. We sincerely appreciate your time and participation, and we hope to connect with you soon. Thank you.